All right. Oops. Found my oops. All right. So let's jump right in. So this week is week 3, wrangling and tidying data. Today we're going to go through parts 1, 2, and 3. We're basically talking about the grammar of data wrangling and a little bit about how to deal with single data frames, and then we'll do the application exercise as part of the 3rd slide deck. So I'm going to jump right in. Actually, this let me share just the slides so you can see them better. Okay, tidying data. Can you see that okay?
Yeah, it's fine.
Okay. All right, so it's about tidying data. Let's jump in. So it starts off with this quote by Leo Tolstoy, which you can replace families with data. Happy families are all alike, and every unhappy family is unhappy in its own way. So it's a lot like tidy data. Tidy data has a lot of things that are very much alike, and untidy data can be anything. So I want to just talk about the characteristics of tidy data. And basically, it's relatively simple, but it turns out that it's easy to make untidy data. So the characteristics are really, there's only 3. Each variable is a column. So every column is a variable. Every observation is a row. And every type of observational unit is a table. So we'll go through some examples. Characteristics of untidy data, it could be all over the map. There's lots and lots of ways to make data that's just not easy to process. So here's an example of untidy data. And if we just use the little rubric of every column being a variable and every row being an observation, can anybody see things that may not fit that model?
Well, the years.
Mm-hmm. So there's a bunch of cells that are merged that are trying to denote the dates of important things. Yep. And then the variables there are variables in the columns. They could be laid out differently, but the big difference here, though, is the merged cells make it really difficult to do something with. Basically, you just have to remove them to do something about them, and maybe you would, to make this tidy, you would add another variable called like important dates with a date field, and then the description of those important dates instead of them being completely separate from kind of the rest of the table. So that's an example of untidy data. Here's another example of untidy data. Can anyone see what this one is? It's not immediately obvious, but I'll jump right in. So the column A, the heading of column A is the actual title of the table. It's not the variable name. So the variable name would be like the country, but this is basically putting the title into there. So if somebody read this into a data frame, the name of column A wouldn't be country, it would be the title, which is this estimated HIV prevalence. And here's another good example, which is this comes right from the census data. This data is, you can see that it's employment status, and then it tells you about a bunch of different summaries for the population of 16 years and older, in the labor force, civilian labor force, all these different summaries. But basically, this is all summary data, and so it actually isn't, it really isn't the basic data at all. When you're talking about tidy data, you're not talking about summary data as much as the actual data observations. So the actual data that was used to make these summaries might be tidy, or now we don't know. But this data, one, it's summary, and two, it's very difficult to get the subject. The subject is it's not one observation per row. It's all these different summary roll-ups. Anyway, so we just talked a little bit about summarization. So just want to point out that a data frame or a tibble can be data, or it can be summarization of the data. So, and this is kind of review, but if I just output the data, like in the Star Wars data frame, right, there was the character name and then some information about the character. So each observation was a character. And on the right side, you see basically this is sort of a summarization of counting out how many feminine and masculine and NA genders there are in the data set. So I mean, if we go over and look at the code, you should be familiar with this. You can pipe your Star Wars into the select function, and it will just select out these variables out of your data frame. If you wanted to summarize, you would sort of do something different. You would, group by your gender and then summarize by your summarization metric, say mean.
Can you go back to the output real quick?
Oops, yeah. So this is really.
What does select do again?
Select just selects columns from the data frame. So
Okay, so there's a bunch of other columns, but we're just doing.
Yep. There was like, the starships that they were in home planet and language and things like that, hair color and eye color.
Can you go back to the code one more time?
Sure.
Okay, got it.
Yeah. So that just trying to differentiate like the raw data from the processed data a little bit. Let's keep going. Oh, sorry, that's the end of the first one. So that's the end of the first slide deck. It's kind of short. I'm going to jump right into the second slide deck, and this is really going to get more into like the grammar and the different functions and stuff. So this is grammar of data wrangling. We talked about grammar of plotting, the grammar of graphics last week. So this is sort of a similar but different grammar for data wrangling. Okay, let's jump right in. So this one's called dplyr. So this is a package in tidyverse, and I guess it's pliers. I'm not sure what the D part is, but it's like pliers is a tool to like twist your data around and make it tidy. I think that's what it's trying to represent. Anyway, the grammar of data wrangling is about all of these things that you can do to manipulate the data to make it in a form that you want. And so the functions in dplyr in this grammar are verbs and example verbs, and these are verbs that we use a lot, and there's a lot more of them, but these are ones that we use quite often. So select we just talked about, right? There's picking columns, variables out of a data frame. There's arrange, that's to reorder or sort rows. And then there's slice. I'm not sure if we use that yet, but that one is to get certain rows sort of by index. I could pick like rows 1 through 5, for example, but using slice.
What do you mean rows 1 through 5? What's an index?
It's the row number you're on. So rows.
Really is row number? I thought last time when we used slice it was something with the variable. It's just the row number, huh?
Yeah, filter is what you would use if you're gonna do using variable names. So we've used filter quite a lot, right? You could say like, if eye color equals green, you would pipe it into filter and say eye color equals green, and then you only get characters whose eyes color are green. Other ones are, for example, distinct. So that tells you all of the unique elements of a given, generally a given variable for all the rows. So if you want to find out how many categorical samples factors there are in a given variable, you could use distinct. And so like you would use that if you wanted to find, remember in the lending example, there was the home ownership, you could have mortgage, rent, or own. If you use distinct on that column, it would tell you those 3 variable names, right? Or tell you the full set of unique names, which is kind of nice to have if you want to use it for selecting. Mutate, we've used a little bit. That basically adds new variables. So you can make calculated fields from other fields in your data frame by using mutate. And then we just talked a little bit about summarize, and that reduces the variables to summary values like a mean or a median of a given variable, and then we've used group by also, and that groups your data by some categorical variable. And we've done that quite a bit for, again, like for home ownership, we did it for own and mortgage and rent, and we've done it for a couple other ones too.
How is group by different from filter?
So group by will group your data by a categorical variable, and then you can, and then if you summarize after you group by, you'll get summaries for each group. Whereas filter will basically subset your table into a smaller table that only matches the filter conditions. We'll do examples of them and it'll become much more clear. So I think let's wait on that and we'll go to some examples. But first we're going to talk a little bit more about just the rules of all of these verbs, all of these functions in dplyr. So dplyr is like the main tidy package, like for tidying data and wrangling data. And the function is always conformed to these four things, right? The first argument is always a data frame, and of course there's going to be an exception. Immediately there'll be an exception when we get to pipes, but ignore that for right now. The first argument to a dplyr function is a data frame. So if I said select, the first argument of select is going to be the data frame name, and then the subsequent variables will be column names. That's the first one. The second one is, okay, that's what I just said. The subsequent arguments after that data frame is what you want to do. And so in select, it would be to select those variables. In other ones, it would be other stuff. A dplyr function always returns a data frame. So even if that function only selects one variable, for example, you'll get back a data frame with one column in it. You won't just get a vector back. So that's a detail you'll run into. Probably you'll bang your head against and then figure it out. But it always returns a data frame. It's a good thing to remember. And then the last thing is, this is a little bit of a programming thing, but it never modifies data. It always returns a new data frame. And so it never actually modifies the contents of an existing data frame that's coming in. That's important in that if I take a data frame and I pipe it into a dplyr function that changes the contents, it's actually not going to modify the thing that I piped in, unless I reassign it. But in general, it will not modify anything. It's only going to create new data, and then you assign it. You can assign it to something else or pipe it into ggplot or something. So those are the rules of the dplyr function. So let's jump into some examples. So here's the hotel's data frame, hotel bookings. I don't think we've seen this before. So there's data from two hotels. There's one resort hotel and one city hotel. The observations in the data frame. So this is a tidy data frame. Each row represents a hotel booking. And the goal for the initial data collection was to develop a prediction model to classify a hotel, the likelihood that any booking would be canceled. We're not going to do that, but that's just background. Okay, so the first thing we do is we're going to create this data frame hotels from the CSV file, from the data. So the data's in a CSV file, comma separated values. So it's just like a text file and all the data separated by commas. Anyway, you can use this read_CSV function to read in a file and stick it into a data frame. So that's the first thing we're going to do. And then we can look at it. Once we've got this hotel's data frame, there's a bunch of stuff. You know, we've done this in homeworks and stuff. You do names, it tells you all of the names of all of the variables or the columns in the data frame. And there's lots and lots of them in this data set. But for example, like what kind of hotel is it? That's the categorical. It says if it's a resort or if it's an urban hotel. Was it canceled? What's the lead time? And a bunch of other stuff. And then there's a bunch of stuff about like the booking characteristics, like how many adults, how many children, did they get a meal, that kind of stuff. So that's names. The next thing you could do, another thing you could do is just, you could glimpse it. So we've talked about glimpse a little bit. It's kind of like names, but it gives you a little more information, which is like, it'll give you all of the column names and then their types and then some examples of the first few elements in each of them. So you can see here, if you glimpse it, you can see there's 119,000 rows, 119,390 rows, and 32 columns. So this is a pretty big chunky data set. So we talked about select, right? So if I want to just select a column, say I only care about lead time, which is the number of days between the booking and the arrival date. I can just use the select function. I can select, and remember, hotels is the data frame. That's the first argument in any dplyr function. And then if I say lead time, that's the name of the variable that I want, and it'll output me. If you remember, the hotels has 32 columns, but I use select. Now it's only got one column, but it's got the same number of rows. So all it did was select the one column, and it returned this data frame with just the one column in it. Okay, it's pretty simple. Let's keep going. So this just breaks it down, right? I'm going to go over it again. So you start with the verb, which is the function name, right? I'm going to select. This is the data frame. It's the hotel's data frame, and then the variable that I want, which is lead time. So that's that. That's the output. That's the result. Okay, we just went through that. All right. So let's just keep going. So we talked about this. So this is just trying to reinforce this idea that the functions expect a data frame in and always put a data frame out. So data frame in, data frame out. You can select multiple columns if you want to. I think we've done this before. So if I wanted to select hotel and lead time, I could do that, and that's what you'd get out. And then there are things you could do after you do that, like, for example, arranging. So if I wanted to do arranging, which is to sort the result, then I would do the select function. Now I'm starting to do piping here. I'm going to pipe hotels into the select function, and then I'm going to pipe the output of that into the arrange function. And this says DESC means descending order. So I want to arrange the output data in descending order of the lead time variable. And so you can see after that arrange and descend in descending order of lead time, the largest value is at the top. So the hotel is whatever it is, and if I've arranged the output so that lead time 737 is the highest, 709 is the next one, 629 is the next one. And there's a bunch of 629s, which is kind of weird, but it is what it is.
Pointing out this is a confusing example because the data frame is named hotels and the column is named hotel.
That is a little confusing, isn't it? Yeah, they're completely different things. Yeah, hotel is just a variable in the hotel's data set. Yeah, actually, I like to name my data frames. I always name them DF something. Like I would name this like DF underscore hotels or something like that, so you know it's a data frame. Yeah.
Right.
All right, let's keep going. Okay, so we just talked about a little bit. We've used pipes before. We've talked a little bit about pipes, but now we're going to just talk a little more like actually introducing pipes here. So pipes. So what is a pipe? Okay, a pipe is a sort of a general mechanism in programming which enables information to be passed from one process to another process or from one function to another function. And it makes it really convenient and easy to read once you sort of get what it's doing. So here's my example. I've got hotels, my data frame hotels, and I'm going to use the pipe operator to pipe it into select. And remember, we said, like just about a few minutes ago, that every dplyr verb, the first argument, is a data frame. Okay, well, this breaks it immediately because you don't see that there's a data frame in the argument. And that's the thing that pipes do is when you're piping things, it becomes the piped part becomes the first argument to the next dplyr function. So that's why
it's a confusing example, because normally you'd put a data frame name there, and the data frame is almost the same name as the column name.
Right. So I'm piping the data frame hotels into select, where the first one would be the hotel's data frame, and then I'm going to select hotel and lead time. Yeah, you're right. So we're going to start with that data frame. We're going to pass it to select, and then we're going to select lead time and hotel and lead time, I mean, in that order, right? And then we're going to pipe the output of that, which is just a data frame with two variables in it, to arrange. And arrange is going to do the arranging, and then the output of arrange is this data frame that you see here. So I hope that makes sense. Although you're right, Pete, it is it's a confusing example, and maybe I'm going to add a little d after that so that it's more clear. So just as an aside, right? So the pipe operator is implemented in a package called magritte-r, and like I said at the beginning of the course, people who do programming love puns, and so I don't know if anybody knows much about Magritte, but anybody know why this might be called Magritte? Why this pipe operator might be in this?
No. He's an artist, right?
Yeah, he was a surrealist, and so he one of his famous paintings was this one down on the bottom left. Anybody know French?
Does it say it's not a pipe?
Yeah, this is not a pipe. So someone thought that was cute, and they decided they were going to re-implement the idea with the pipe operator, and they're going to call the package that does it Magritte. And so this is not a pipe. It's a picture of a pipe. Anyway, so that's what they did. So that's take it for what it's worth. All right, so we're going to talk a little bit about programming stuff here. It's not too complicated, but we're going to try and illustrate it with sort of a pseudocode and try and unwrap why pipes are interesting and sort of how they're working. So there's this sort of fictitious kind of sequence of actions that I'm going to do. I'm going to find my keys, and these are all, I'm going to do these in functions. I'm going to find my keys, I'm going to unlock my car, I'm going to start my car, and then I'm going to drive to work, and then I'm going to park. This example was made before COVID. Now, if I was going to do this in like pseudocode, like as a programmer, if I didn't have pipes, the first thing I'm going to do is I'm going to find my keys, find keys. Okay, that's my pseudocode. And then with the result of finding keys, I'm going to start my car. And that's just kind of how functions work. The result of this function is fed into this function, and then with the result of starting the car, I'm going to drive. I'm going to drive to work, and then with the result of that, I'm gonna park. So that's kind of the traditional functional way of programming this pseudocode. And with pipes, it's just a much more natural sequential order of things that I'm going to do. I can basically make the same statement, but I can find my keys here, and then the natural order is that I could just pipe the output of that to starting my car, and then the output of starting my car I can drive to work, and then the output of that I can use it to park. So it's a much easier to read structure, and so actually I would encourage everyone to sort of do that unless there's a really good reason not to. That it's so much easier to read the code of piping once you kind of get used to it. Stop me if any of this is confusing and doesn't make sense. So the last bit here is just sort of we want to sort of just acknowledge that there's that we've talked about sort of piping and layering, and they're in ggplot versus dplyr, and they're kind of similar ideas, but they're sort of different, and they use different terms, right? So the percent greater than percent is the pipe, and we're piping output of functions to other functions. And in ggplot, we use this plus operator, and it's used for this idea of layering, but really it's very, very similar to piping. And the terminology could have been the same when they developed it. They could have actually made these operators exactly identical, and it would have probably reduced some confusion, but they were just developed by different people at different times. And so just like you may run into this just by making a mistake. If you're trying to do piping and you mistakenly use the plus operator, you may not get a very fantastic error message, but you will get an error message because this, if you try and do a plus on thing that's not a ggplot, it'll just fail because it doesn't know what this stuff is. And of course, the right thing to do is to do the pipe operator. In ggplot, actually, it's a little bit smarter. If you try and use the pipe operator in ggplot, you will get an error message that says, I think you mean to use the plus, not the pipe operator. And then that'll help you fix those problems. And then the code styling, right? So I do actually think that code styling is important. You really do. You don't have to, because syntactically it's okay, but try and make like a space between these operators, between like your statement and your operator, and then every time you've got a pipe or a plus, unless it's a really, really short expression, add a new line, because it'll be so much easier to read for you, and you'll make less bugs. You'll make less error. You're less error prone if you do that styling. So that is the second one. And the third one is the one that's going to jump into the application exercise. But we're only at 7:30, so I think I'm going to just keep going, and we're going to basically start working with a single data frame and doing some examples on it. And then as part of this slide deck, we're going to go in and out of the application exercise. So let me do a few slides, and then we'll jump back and go into this this example with the data wrangling for the application exercise. And then at 8 o'clock, we'll take a break. Okay, so we're going to work with a single data frame. So we have a single data frame, and we want to slice it and dice it and process it. I don't know if we want to juice it. Okay, so we've already looked at this hotel bookings a little tiny bit in the last slide deck. So this is data from 2 hotels, a resort hotel and a city hotel. Each observation is a row, is a hotel booking. Okay, so we're going to do some stuff with it. We're going to select it and arrange it and slice it and dice it. So we've already done this. We've piped hotels, the data frame, into select, and we selected 2 variables, the hotel and the lead time variable. So that's easy. I think that's just review. So there's a bunch of stuff I can do with select. I can just select what I want, or I can select what I don't want. So if there's a variable called agent, and I don't want it, but I want everything else, I can say minus. So I can minus out the agent, and it will give me 31 columns back. You remember there's 32 in the original data set. It'll give me 31. It'll give me everything but agent. So there's a bunch of operators that we're going to go through that describe the things that you can do that help you to select stuff. So you can select a range of variables. So you need to know that you need to know the order of your variables in order to do this, but you can select from hotel to arrival date month if you know that that's what you want. And if you did that with this data frame, you would get 5 variables. You'd get hotel, is canceled, lead time, arrival date year, and arrival date month. But you do have to kind of, if you do names or something on that, you can see, like, you could pick the ones out that you want and use this. It's actually handy to view. And the little colon means.
I'm sorry, I didn't follow that. Could you go over that again?
Yeah. It would be easier if I could show you the list of names, but if you do names on hotels, you're going to get 32 different names, right, in your list, because there's 32 variables. And if you do names, you'll see that hotel comes before arrival date month, and if I select hotel colon arrival date month, I will get all of the variables between hotel and arrival date month, including hotel and arrival date month. Does that make sense?
So the colon is kind of a new operator here.
I guess it is. Yeah.
So
That's
could we alternatively do 1:5 or something?
Yep.
Do the same thing.
Enumerate it by the number. Yes, and
but just to explain, that colon is new. We don't know about it yet.
Yeah. Okay. Nobody's seen that one before. Yeah, the colon is like a range. It creates a range of things. So in this case, it's a range of variables. But you could, more commonly, people use like numbers. So 1:5 would be.
But that'd be rows, and in this case, it's columns.
In this case, it's columns. Yep. But if you
if you use the character variable name, then it's columns. If you use the number, it's rows.
No, in select, it's always columns. And so
I thought you said it was, if I wanted to do rows 1 to 5, I could just do select.
No, you have to use slice. It's a different operator.
Oh.
I think that's the next. Oh no, we're good. Okay, so let's go through all the, some example selectors. And there's a dictionary and a cheat sheet for how to do them when you start actually using it. You want to look up. There's a bunch of stuff like, for example, if I want to select all of the variables that start with some text, like a lot of the variables in this data frame start with arrival, the word arrival. So there's arrival date year, arrival date month, arrival date week, number, blah, 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 blah. So if I could use the start with, if I want to just get all of the columns that start with arrival, for example. And you can use, there's ends with, so like there's a bunch called type at the end, deposit type, customer type. You could select those, ends with type. And so there's a lot of helpers, and this is just a small list of them. Contains, I use contains a lot, so that's kind of like you give it a little substring, and then any of the strings that contains that little substring, like type, it will pull out. You can do numerical ranges. One of is if you have, you can make like a character, a vector of strings, like a vector of names or something, and then it'll give, it'll match any of them that are in there. Everything matches everything. There's a use for that. I forget what it is. Last column gives you the last column. So this is just like a laundry list of helpers that allow you to select stuff. And then the last one's regular expressions. That's pretty complicated, regular expressions, but it's a pattern matching grammar that you can use if you have a complex thing that you want to match on. And we're going to get into that, but a little bit later. If you do this question mark tidy select : language, it'll tell you all the different select helpers. And there's also, they're in the cheat sheets too. We'll come back to this one. Okay, so we talked a little bit about select, and now we're going to talk a little bit about how we do a range, right? So here's some examples. If I'm going to select adults, children, and babies, right? So that's out of those hotels, like what were the booking types for these different people, age ranges, and then I can arrange by babies. And if I select these three variables and arrange by babies, I get a bunch of zeros, and that's maybe not what I want. What I really want is I want it in descending number of babies, and so I can see that the largest number of babies in a booking was 10. So there was a booking with 2 adults and 10 babies. No idea what they're doing with 2 adults and 10 babies in a booking, but and that could be also a data entry error or some kind of data error, because seems like it's kind of unlikely. And the next one's a little bit weird too, 1 adult and 9 babies. After that, it kind of makes sense. There's 2 adults, 2 babies, and goes from there. But anyway, that's how you would use a range to do that. Now here we're at slice. So if I only care about a few rows, I can slice it. A lot of the time, you can use slice just to sort of get a sample of a very large data set. If you want to do some processing on it, and 120,000 rows might take longer than you want to wait, you slice a little bit out, and then you can do some stuff with it. So that's slice. So slice is like select, but it's on rows, not columns. And then here's just a little note for comments. You can comment pretty much any line you want, and a comment starts with this little hashtag, I guess. And if you hashtag your line, then it just gets completely ignored. So in this example here, I'm piping hotels into slice. And if I commented out this select, then I would be piping hotels into select, which pipe then into slice. But because it's commented out, it's not going to do that. So it's just something to keep in mind. And also, if you want to debug something, a lot of the times you might comment out a line like that. All right, we've talked a lot about filter, but we're going to talk more about filter because there's a bunch of stuff you could do on filter. So filter is to get some set of rows, some subset of the data frame based on some attributes. And so here's an example of hotel equals city hotel. If I only care about the subset of this data frame, which is just city hotels. You remember hotel is either city hotel or resort hotel. So this is kind of half of the data frame ish. You can say filter on some variable equaling some value.
And the 2 equal signs is always the way you do equals, or?
That's very important. Yeah. Otherwise, it's trying to do an assignment and it'll just barf on you. Yeah. Actually, in some languages, it won't even tell you that it's wrong, and but it'll do the wrong thing. But this one, you have to use 2 equal signs. Yep, that's the equals equals operator, and there's a bunch of other operators we'll talk about. So here's another one, which is if you want to filter for several conditions. There's if you want to filter on adults is 0, adults equals 0, and children is greater than or equal to 1. That's the greater than or equal to operator, right? And this little comma here means it's an and operation. So it's going to filter out all of the observations where adults is 0 and children are greater than or equal to 1. And then it's just selecting a subset of variables to show. So that's kind of interesting. So there's a bunch of bookings where there are no adults in the room, but there's a bunch of children. Hopefully those are next door to the adults, but there's not enough data to tell you. So that's an example. So there's other examples if I wanted to do other things like, for example, an or. So the comma was an and operation. This vertical thing is an or operation. So I can say, I want to know all of the observations where adults is 0, but either children is greater than 1 or babies is greater than or equal to 1. And then I can get that information. And so these are called Boolean operators, and there's a whole little language on that. But sorry, was there a question?
Yeah, so here I got adults and children, and then I got the or. Does that apply to the adults and children, or just the children? The children or babies and adults, or
these are separate expressions. So there is an and Boolean operator if and parentheses if you want to do a complex one, but these are the independent expressions that are and together. Yeah, so the or is takes precedence in that expression, and then it's anded with those adults.
Okay.
Let's keep going quick. Yeah, okay, so there are a bunch of logical operators, and you will end up using these probably quite a lot on numerical variables, but these are all the operators. You can do a less than or equal to, a greater than or equal to, then there's exactly equal to. The exclamation point is not, so that's not equal to. You can explicitly do an and function if you want to, instead of putting them in separate expressions with the comma. Then there's the or operation. And then there's these special tests for the NA. You can't say equals NA because NA isn't the same thing as like the string NA. So there's these operators called is NA or not is NA for missing values. And these are super important because most of the time data sets have missing values, and you want to be kind of explicit about whether you're including or excluding them for certain operations. And then there's this in operator, which is like a string match where like if X is in Y, it's kind of like the contains operator. It's like a substring. And you can not it also if you put it in parentheses. And then there's just the straight up not X. So I could say, not something. We'll do a bunch of examples on these. The best way to learn these operators and the Boolean expressions is through doing examples of them. So that's what we're going to kind of do now. So why don't we jump over, start up your RStudio and pull in this application exercise. I'm gonna open up a new one over here. So I'm just gonna copy this. I'm gonna go to Git and get the Git repo, and then I'm going to go to my RStudio, and we got to bootstrap everything up. So everyone should be booting up their RStudio and doing their package installation and stuff. project. Oh, I already did it once. Let's do it from scratch.
I can't find it in the repository. Could you send it in the chat?
Yeah.
Thank you.
Yeah, I don't have it either.
Weird. Oh, it's in the YaRDS.
It's in the class outline.
Yeah, it's on the home page. I'm just gonna, I'll paste it in.
Oh.
Sorry. Yeah, you're not gonna, application exercises don't come into your GitHub because you don't submit them. Just like for future reference there. Oops. If you go to the home page. Sorry, my system's super slow. And then go to like this guy, then it's in the actual section 3 things. So okay, everyone's got Git repo. You can install all your packages. So this one's a little different. So the application exercises, if you remember, are all of the stuff is in the markdown file. There's no instructions. And so we'll just go through the first 4 in place here. Remember to use preview in viewer pane for a better experience. Net.
He's got something on.
Gonna display your screen.
No, I don't know why it's. Oh. It looks like you're supposed to use a squiggly for skim and not a parentheses. No?
Did you jump ahead?
No, I'm just doing exercise 1.
You did. Okay, so if everyone's, I guess we don't have to wait. We've done this enough times. Did you run your tidyverse and your skimr at the top?
I ran library, yeah, tidyverse and skimr.
Okay. Yeah, so load up your data if you care about running it in the console. I always like to just have it there available.
Yeah, I just tried skim hotels in the console and it's not working. It does, for some reason, when I type skim, then it comes up with a squiggly bracket article, but it doesn't start to come up with any of the databases like hotels. It says data null, but
if you type skim open parenthesis, oh, data. Yeah, the data part's the part that you want. You just write this, the hotels, you want to say hotels in.
Yeah, it says object hotels not found, but
That means that you didn't load the skimr library.
But I did load skimr. I'll do it again. I just copied and pasted it. Sometimes when you copy and paste stuff, it seems like the carriage return goes on only the first thing.
Yeah, it's a little odd. I'd like to, if you hit that little green button, you're kind of guaranteed that it'll run. Yeah, you got to be a little careful about the cursor when you copy and paste stuff, because sometimes it doesn't go where you think it's going to go.
Seems like it ran because it didn't do anything the second time I typed it in there.
I'm sorry. You know what? Did you do line 14? Hotels equals read CSV blah blah blah.
No, I thought that that was just a comment about where hotels came from.
No, I'm sorry. I missed.
Okay, so that's a CSV.
Yeah, it's reading the actual CSV file. That's how hotels comes in. It's not part of the package. Sorry, my bad.
Gotcha.
So, I mean, exercise 1 basically is just doing the skim function,
Okay, got it now.
but it's already there. Actually, the output of it is actually in exercise 1. I mean, the idea.
And that's not what it looks like to me.
Well, yeah, when you do it in the console, it looks very different than you do it when you do it in the R for some reason. In the R Markdown, yeah. But it's the same data. So Skim has a ton of stuff. Like the first table is the data summary that says how many rows and columns. And the next one is like variable types, character, variable types, date. It gives you a lot of information. Kind of too much information. So it's Skim is actually it's not a data dictionary, but it does give you a nice overview of all the data in there. I haven't used Skim very much. Okay, so that's exercise 1. Is everyone kind of there? All right. I'm assuming everyone's there. You want to jump on to exercise 2, which is how many are people traveling on a whim? That's what it's saying. So the idea is to find out how many people booked hotels where the guest is not from the US and the lead time's less than 1 day. Assuming that, I guess the hotels are all in the US. So this is the kind of these are the filter operators that you might want to look at. So the first one is the not operator. So I want to replace this guy with a country not equal to the US.
So exclamation part, exclamation part, right?
Yep. And
equals equals.
No, just a single equal. So bang equal, exclamation equal. Yep.
Wait, filter. You put in nothing up there.
Well, I'm on line 44.
Right.
Oh, yeah. This is another way to do layout. If you have multiple arguments, is to do this sort of filter, open paren, return, first argument, comma, return. Yeah, it's just a nice way to lay it out. You don't have to do that. You could put country on the same line as filter. But this is just sort of convenient. And then lead time, you want lead time to be less than 1 day. Less than 1 day. Lead time is 0 days. So that's less than 1.
Yeah, I'm gonna try and type 1. It comes in as a dash.
Dash.
Right.
Are you doing it in the console or?
Yeah, it's not doing it now. I don't know why, but it was coming in as the thing under the tilde.
Oh, the tick.
Yeah. Anyway.
Yeah, you should be able to execute it, and it would tell you stuff. Oh, your eval is on false too. I forgot that one. You got to get rid of eval equals false, or set it to true in order for it to evaluate that expression. I'm just going to knit that one quick. I did the skim. We did. So we are looking for guests who are not from the United States, whose lead time's less than a day. And I got 6,174.
Unexpected exclamation point. So you do country and then what?
Space and then
Oh, I
exclamation.
left out the equal. Says you're supposed to put 2 equals, and you said no.
No. You want to show me what you got?
Sure.
Or you can you see my screen? That's the.
Yeah, I have the quote in the wrong place.
Hmm.
It's still not working. Let's see what you got again.
Do you want to display what you got, or?
Sure.
Hotels piped into filter, open country. Oh, you've got a quote before the exclamation point. So you're not quoting that the not equal. Yeah, get rid of that and then put a double quote before USA.
Double quote?
Before USA, though, you got a quote between, yep, and then put it.
All right.
Nope, it's before USA. You got it before the equal sign. Yeah, and get rid of that other quote. That should work. Yep, that ought to work. So knit that, and that'll get rid of your render error. $6,174. Yeah, that's what I got too. 6,000 bookings made with a lead time of less than 1 day from people who are not from the US. All right, let's go on to exercise 3. Okay, this one is going to be another sort of Boolean expression, filtering for at least one child or at least one baby. So basically you want to replace the at least and or with those operators. So at least, what operator would you use for at least? Or use greater than or equal to 1 is at least 1. And the or is the or, that vertical character.
Where is that again?
It's above the backslash, above return, above the shift backslash. You gotta shift. Yeah.
And greater than
Yep.
equal.
Greater than or equal to. Yep. 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 That's right. Greater than or equal to. Yep. And then zip that one, and that tells you how many have lots of kids. Oops, and set your eval to true if you want to knit it, or get rid of the eval equals false, otherwise it won't evaluate it. It's not a valid expression. And I got 9,332. Oops.
What does the false thing do again?
You can't commit that because it's not in your. This isn't an exercise you can commit. Sorry, what were you saying?
Oh, I can't commit it.
It's not your personal repository. It's a general purpose repository for the whole class.
So what's eval again?
It just says whether or not that chunk should be evaluated when the R markdown is rendered. And so it's set to false because with all those underscores or the at leasts, it would fail. It would fail with syntax errors. And so they just said, oh, we'll just set it to false.
Got it.
What'd you get? 9,332. That's how many have at least one in a child, and at least one baby.
Right.
I think we're supposed to do, let me just go back to the slides. I think, okay, we're supposed to do exercises 1 through 4. So that was 3. Let's just quickly look at exercise 4. Okay. So now this one's a little bit more complicated. Do you think it's more likely to find bookings with children or babies in city hotels or resort hotels? So we're going to test our intuition. First, we can make a hypothesis. And we're going to use filter to determine the number of bookings in resort hotels that have 1 child or baby. And then do the same thing for city hotels and then compare results. So what I would do is I would start out with the thing that we just did in exercise 3, because that has most of the stuff we're going to need for exercise 4. So I'm going to copy and paste that. And then I'm going to add a filter command to filter out on resort or city hotels. Oh, actually, I can just add it. I'm in the filter. I can just add it as another statement. So how would you add it as another statement? So that in filter, you can have bunches of statements, and they're comma separated. So you can have.
So you could do filter. What is it?
Hotel.
Hotel equal resort.
Yeah, well, it's resort hotel. If you look on your markdown, on your rendered markdown, there's an example on at the bottom of exercise, right at exercise 3 output.
So filter hotel equals, right?
Right. Make a little space there. It's nice to have the spaces just for readability. Yeah, and then right.
You can still see my thing.
Yep. And then you need it's comma separated, so you need to make a comma there, and that's it. That ought to run.
But that's not counting anything. We'll just be
The
able to see
output tells you the count. You could pipe that to count. You could do a bunch of stuff, but let's not do that yet. You could just look at the output table. It tells you that there's however many, I forget the number. We'll do counting and summary in a bit. It's a little more complicated. So you can do the same for city hotel, and then you can, if you knit them, then you can see the those answers. Yeah, so you got 5403 for City Hotel. Did you get 3929 for Resort Hotel? So they're pretty close. There doesn't seem like there's a huge signal. So anyway, that's the first 4 that we were supposed to do. Maybe we should just take a 5-10 minute break. Or if you guys want to keep going or take a break.
What else do you have left for today?
There's 2 more parts to this application exercise in the slide deck. So we're going to do a few slides, and we're going to go back to the application exercise and do 2 exercises, and then we'll do a little bit more slides and a little bit more application exercise. Probably 30-40 minutes worth of stuff.
Yeah, I'd like to take a break.
Okay. All right, let's come back at, I don't know, when do you want to come back? 8:15?
Yeah.
Okay. It's 8:08 now. All right, we'll come back at 8:15.
Okay.
Thanks. Here, I'm just going to steal the screen back. So the next part is this. Okay. All right, I added a DF to all the hotels. I'll be there in a few minutes. I'll be so confusing. Do this first. We back? Let's see. Well, cool. Let's see. Well, are you guys back? I don't know if Shamil's coming back. Should we keep going? All right, let's keep going. Jackie, are you back? Pete, you back?
Yeah.
Okay.
So what are the numbers for the exercise? The 3929 and 25403?
Oh, yeah, yeah. Yes. That's right.
Okay.
All right, so we talked about select and filter and arrange. Now we're going to talk about distinct and count. So we talked a little bit about distinct, and so distinct for any variable will give you all of the unique values of that variable. So it really only makes sense for like factors or categorical variables. So market segment is an example. There are only 8 market segments. And so if you pipe hotels into distinct, and then you pipe it to a range, you'll get a list of all of the, well, you get a tibble, which with one variable that has all of the market segments arranged in alphabetical order from A to Z. And then on the right here, another way, so you can use distinct on multiple variables. So on the right-hand side, the example is I want distinct hotel and market segment. So the hotel variable only has 2 values, city hotel and resort hotel. And so for every combination of hotel and market segment, it will give you a result. And then you can arrange the output by alphabetical order in this case, it's first hotel type. So city always comes before resort because C is smaller than R. And then within city, you get the alphabetical results for market segment. But if you turn it around the other way, it would order it the other way. And I think there's an example of that. No, maybe there isn't. I thought there was. So does that make sense? It's distinct. Next one is count. So the count creates a frequency table kind of like a histogram, but it doesn't plot it. It's just for counting. So it's basically, you could actually plot this and make a histogram without using the geom histogram function. I don't know if you'd want to, but this just gives you a count of all of the. So if I wanted to count market segment, for example, it would count up all of the entries for each of the market segment values. And you can see like for online TA, there's lots of 56,000 values. And then the aviation industry has a small number, 237 bookings. So this is just like the segmentation and how they're done. Again, and they can count them. So it's a frequency table. And I can also sort. So most of the time I want to do this in sort of what Pareto order, right? From larger to smaller, right? So it tells me that the largest number of bookings came from this one, followed by offline, TIATO. I'm not quite sure what that is, but I think it's like a travel agent. And then groups, direct, corporate, getting smaller and smaller. So that's really nice to have to give me like a priority order kind of thing. And if I don't want to do just the simple sorting, I can do some arrange on stuff. So if I wanted to, for example, I could do basically exactly the same thing here using arrange instead of the sort. If I wanted to, it's just another way to do it. So a lot of times there's lots of ways to do the same thing. But so in this case, I can get exactly the same as the sort equals true on the right-hand side, but if I wanted to arrange it in ascending order, I would have to use the arrange function. So one of the outputs of count is a variable named end. So that's an implicit thing that happens in the output of count. So count makes that up. You have it only on the output side of that. So that's just something you got to know. And again, we talked about counting for multiple variables. So here's a count for hotel and market segment. And it gives me for every combination the counts of the combination of those. And then this is the example of going the other way, right? If I can count by the order matters. So on the left-hand side, it's gonna group first by the hotel and then by market segment. On the right-hand side, if I count by market segment, the order of my results comes out differently. It comes out first by market segment and then ordered by hotel. So you can see for aviation, there's only city hotels. For complementary, there's a city hotel and a resort hotel. And then for corporate, there's city and resort and that kind of thing. Okay, so now that was distinct and count. Now we're going to go back and do exercise 5 and 6 in our studio. So let's pop back there. Go up to exercise 5. So now we're going to create frequency tables. We're going to count the number of adults in a booking. We're going to display the results in descending order so that the highest one is at the top. So how would I do that? Well, I would go back to the slides. Well, I'm going to do that quick. And I'm going to look at this and say, okay, I can pipe hotels into count. And the count that I wanted to do was adults. Is that right? Yeah, counting the number of adults in a booking. So I can take hotel, pipe it into count, and I'm counting adults. I think that might be it. Oh, and then I want to arrange it in descending order. So I'm just going to arrange it. I can say sort equals true, I think. And I'm not conforming. Oh. Hey, Shamil, we just we went over a couple new variable functions, and now we're going to basically do them. So if you go to exercise 5, you can probably catch up.
Okay, yeah. Sorry about that.
Sure, no problem. So let me.
Why did you pipe hotels? I mean,
that's what. So hotels is the data that we're looking at. That's the thing. Here, let's go back to here. So hotels is the data frame that we're interested in. We're always going to pipe that into something to do something. So I'm going to count. I didn't have to. You could say count hotels, comma, but
right. Okay.
Yeah. That's just the pattern we've been using. Yeah. So if I pipe hotels into count, adults, so we can see that let's knit it and then we can look at it. So is that was outside. So let me know when you're there.
Yeah, hold on. I forgot even what pipe looks like. I mean, we can't cut and paste out the slide, so.
You can.
You can?
Yeah. Can you? I can.
Hold on. I got so many windows because I got your screen up, and then let me just get back to the slide deck what that was in.
Oh yeah. You want me to
That's okay. I got it. So what do we want to do again? I want to know the,
You want to make a frequency table of the number of adults in a booking.
so you don't really need to arrange because they're already going to come in descending order.
No, you have to say sort equals true to make them in descending order. But you could pipe it into a range or you could sort, because sort, the default, the only thing sort does is descending order sorting.
Hold on a second. Yeah, I can't see. Not equal. You don't have to end the.
Once we label my chunk.
Pay attention to correctness. What does that mean?
Where does it say that?
In the code that we typed over. Pay attention to correctness and code style, whatever.
Yeah, it's pay attention to the code, your coding style with the spaces and one line per statement and stuff like that, and you should run into fewer problems if you do that. Where are you right now?
Well, I got a 14 by 2 table. Is that right?
Yeah, yep. So let's look at the data. It's kind of interesting. So if you look at the adults variable, right, the first most frequent booking type has 2 adults in it, right? There's 89,000 bookings of 2 adults. Does that make sense? So it's that. And then there's 23,000 bookings of 1 adult, 6,200 bookings of 3 adults, a small number, 400 bookings of 0 adults, usually it's adjacent room with children or something. And then there's then there's 62 4 adults, which is reasonable. And then there's a bunch of goofy numbers, 26 adults, 27, 26. So those are kind of questionable results, right? I'm not sure how often you're going to get a booking for 1 or 2 rooms with 26 adults in it. So that leads us, so I'm assuming everyone got there. Let's go on to exercise 6, which is kind of like drilling in a little bit to see maybe if we can uncover some information about it. So we're going to repeat exercise 6 once for canceled bookings and once for not canceled bookings. So one relatively simple way to do this is to filter by is canceled equals 1 or is canceled equals 0. Or you could group by, but the simpler thing to do is just to filter and make 2 of them. And that's what it's asking anyway. We're going to do 2. We're going to repeat exercise 5 2 times, once with is canceled 1 and once with is canceled 0. So I'm going to filter I know it's called is canceled because they told us it is. So is canceled as a 1 is canceled bookings. And I think I'll make a different chunk for the other one. Just
Quote one?
sorry.
Quote one?
Oh no, it's a number. It's a numerical, so you don't quote it. I'm just gonna admit that big boy up. I hope I didn't make an error. So that was exercise 6. How are you doing?
I made a mistake, but I'm doing okay.
Let me know when you get your tibbles.
So the amount of 2 adult rooms that got canceled is 54,000.
Number of adults that didn't get canceled is 54,000.
Oh, okay.
And for 2 adult, with 2 adult rooms. Yeah.
For two adult, yeah.
I think we're supposed to do 5 and 6 on this one, right? I'll just double check. Yeah, okay. Do you have an error?
No, this doesn't make sense.
Oh, what'd you get?
Well, so for, oh, okay, so is canceled is once. Okay, so a lot of those weird ones got were canceled. They were just mistakes.
They were either mistakes or someone goofing around. Yep.
Yeah.
So
And
all
only
these anomalous
less than
numbers
5 were
canceled.
canceled.
Yep. All of the not canceled ones had 4 or fewer adults in a booking. Yep. So that's
5.
kind of cool.
One has 5. I mean, 46 out of 5. No, 4. I got you.
4. Yeah. Yep. Yeah. Those are that's the index. Those are the row indexes on the left. Yeah. Yep. All right. So cool. Did everyone get there?
Mm-hmm.
Cool. All right. Oh, raise your hand if you didn't or if you got something. Otherwise, we're going to go on.
What's
right.
the answer? So I can check mine.
Well, there are 2 tibbles. One's 14 by 2 for the is canceled and 5
Okay.
by 2 for isn't canceled.
Okay.
And the isn't canceled only has 4 adults. That's the maximum number of adults you'll get in the isn't canceled. So all the goofy numbers are in the canceled category. All right.
So this would be, if we were looking for the cheat sheet for this, there's one that's called manipulation with PURR, but we're using the Diddy or something, or the
dplyr. Yeah,
dplyr.
per is I can't remember what it's for, to be honest. Yeah, it's another package. It's I have used it, but yeah, it's dplyr.
Okay, gotcha. dplyr.
Okay. So now we're going to talk about mutate, which is super cool. So mutate makes a new variable. So here's a nice example of mutating. I care about children and babies, but really I don't care about differentiating, and I just want to know the sum of children and babies. And so I can make a new variable called little ones, and that variable is going to be the sum. It's going to be children plus babies. So then the statement pipes my hotels data frame into mutate, adds the little ones variable, which is the sum of children and babies, pipes that to select, and then arrange. And so what I can see now in my tibble in my data frame down here is that little ones indeed is the sum of children and babies. So 10 plus 0, 0 plus 10, 0 plus 9, 2 plus 1 is 3. 2 plus 1 is 3. So that's kind of cool. That's a computed field that you can add on the fly. And you can do lots of different mutations. So here's a couple of nice samples. Let's look at what they do. So hotels on the left-hand side. So I'm differentiating by resort and city hotels, and I'm going to count little ones and beat in both of those and see how different they are, or if they're very different. So on the left-hand side, I'm piping hotels into mutate. I'm mutating by I'm adding this variable called little ones. And then I'm going to filter by little ones greater than or equal to 1. So I can create this new variable, then I can filter on the new variable and an old variable called, hotel is just resort hotels. And then I can select out the hotel and the little ones to see how many there are. So in this case, there's 3929 observations of a resort hotel having one or more little ones. And I can do the same thing in city hotels, and I can just see that there's 5,400. So there's a little bit more, but not a huge number more of little ones in city hotels in terms of bookings. Okay, that's one mutate example. All right, now we're going to do some more stuff. Let's take a look at what this does. So we're taking hotels, we're piping it to mutate. So now we're creating little ones. We've already done that. Little ones is children plus babies. We're going to pipe that to count, and count is going to make a frequency table of all the combinations of hotel and little ones. So it'll be all combinations with city hotel and resort hotel, and then all little one values between 0 and however high it goes. And then the output of that, I'm going to add a new variable to, which is going to calculate the proportion of all of these values. So basically it's a percentage of each of these entries to the total. And it is not sorted. It's just, it's in the order that it comes out of count. So the first row is city hotel. It's the city hotel 0 little ones combination, and that count is 73,923 bookings. And it turns out that's 62% of all of the bookings. So that's kind of interesting.
So, I was trying to do something with the count n in the homework exercise. So you know how it asked you to count the number of rows? That also used the variable n, like when it displayed it.
That's a different.
And I wanted to just print out the value of n in inline. Maybe I could take this offline, I guess, but do you understand what I was trying to do?
N rows? You're talking about the number of rows?
I used the n rows function.
Sure.
And in the n rows, when it made a table, it used that same parameter n to list the number of, the frequencies of rows. Just like this count uses n. And
Okay.
down at mutate, you're using that n.
Yes.
And I wanted to just print n. And when I tried to do that, it wouldn't work. So say you wanted to do this, you wanted to just print out the number of.
Well, this n is it turns out it's just a variable in a data frame, right? So it's it's just a column in the data frame. So, you know, you can do whatever you want with it. Yeah, I think let's take it offline. I'm not quite
All
sure
right,
what example is. Yeah. Okay, so that's this one, and then I think, okay, no, there isn't another example in there. You could have put this in Pareto order, and anyway, but so this is a nice example of a kind of complicated set of statements that allows you to get sort of the proportion of the observations in separated by how many little people and in which kind of hotel. Okay, now the last two bits are going to be summarize and group by. So summarize is for summary statistics. So very simple example, summarize, it will create a new variable, mean ADR by the mean of ADR is average daily rate. And it is, I think it's just a variable. It's one of the columns in the data set. So I can just, my summarization of that would be if I took the mean of all of those data in that, of all the observations in the ADR column, I would basically get one answer out. And that's what this is doing. All right, so that's what summarize is. It's collapsing your variable, all your observations in a variable or a group of variables into one value. And you can do a bunch of different ones, though. You don't have to just do, well, that's what this just said. Okay, this the changes the data frame entirely means it, you know, it's no longer the data observations anymore. It is summary data, which is completely different. And that's what that's saying. Yeah, it removes all the columns and it just replaces them with the summary data. So if we look at so this is just a note on sloppiness. This note on the left is it will work, but it's not a great idea to do. You really want to rename. You're creating a new variable name, and you want to make it sort of define it yourself. Otherwise, whatever this expression is turns into a quoted. That variable name is this sort of quoted value of whatever the expression you did was, and that's just messy. That's all that. So don't. It's just not recommended to do. Yes, it's just that's a style, definitely style. That was summarized. Now we're going to go to group by. So group by we've used before, and so we're just going to sort of repeat what we're doing here. So grouping by takes your data frame and separates it into groups based on some categorical variable. So in this case, the categorical variable is hotel. There's only two values of hotel: city hotel or resort hotel. So if I pipe hotels into group by hotel, and then I do something downstream, it's going to do that something downstream on each of the groups. And then you'll get one entry for every group. And that's what this is saying right here. I'm going to group by hotel, and then I'm going to summarize by this mean average daily rate, except it's going to give me one entry for city hotel and one entry for resort hotel. That's what it's doing. Okay, and this is a note on the count function, which is a shorthand for this other group by and then summarized by n equals n. The summarize n open close is a function for counting in summarize. So these are equivalent functions. Count is just a shorthand for group by and then summarize by counting each of the groups. It's just a note. Use count unless you want to do something fancy. All right. For summarize, you can do a bunch of different statistics. Like we said before, you can get the min, the mean, the median, the max, a bunch of different statistics for this interquartile range. Anyway, it can be on different variables, but it's all collapsing them into a single observation unless you've grouped it, assuming you haven't grouped. But these are just the same different operations over the same sort of scope. Okay, so now we want to go back and do 7 and 8, and we're going to play with summarize and group by in the application exercise. So let's head back to our studio and go to 7. So this does help if you do have access to the slides and to the RStudio, because then you can cut and paste out, because these are all the basically the slides that I just showed. Here, let me just stick this into the chat so you guys can pop it in, and then you can use the same browser and go between tabs on your browser to get the different stuff that you might be interested in getting. So exercise 7 is basically doing these summary statistics with a group by, which is the example that we kind of just showed. So I'm just going to pop back and go back to group by and summarize. And so this is slide 37. It says, I want to calculate these summary statistics on average daily rate grouped by hotel. Okay, so you can see separately for resort and city. So I want exactly this, except my summary statistics are different. So I want hotels are going to be piped into group by hotel, and then I'm going to pump it into summarize, pipe it into summarize. So let me do that. First, I'm going to rename my chunk to summary by hotel type. And then I'm going to
Does it say by hotel?
excuse me?
Was it by hotel type?
Group by?
It just said calculate minimum, mean, median, and maximum average daily group by. Oh, I didn't.
Hotel type. Yep.
Okay. Sorry,
Yeah.
that was cut off, so I did it the other way.
Oh, okay. And I'm going to pop back here because I'm just going to steal her nomenclature, which is mean underscore ADR. I'm going to go, let's see, let's keep these in order. Min ADR equals min ADR. And then mean ADR equals mean ADR. Median ADR equals median of ADR. Max ADR equals max of ADR. And then I'm going to knit. When you get there, you'll see that there's some kooky data. Let me know if you got any issues with that one.
I got it, but just slow down. I want to get a head start on the next one.
Sure.
Trying to find the filter now on the slides.
So you're on 8 now? You did 7?
Yeah.
Okay. So anyway, let's just talk for 2 seconds about 7, right? There's a couple of strange numbers, right? One of them is very, very high max in the city hotel. And then there's this weird negative value in the resort hotel. And then, yeah, so basically, yeah, number 8 says, okay, well, let's go find out what those are. Let's get some little bit more information about those outliers.
Yeah, I don't have an example of filter. Oh, yeah, there it is.
Mm-hmm.
Okay.
So you don't need a group or anything by this one necessarily if those are unique values, which they probably are.
Huh. All of a sudden, I can't. There's no little arrow to run my chunks anymore.
Huh? That's odd.
Can only knit.
It could be running something.
I got an error. I just did filter min ADR.
Oh, you don't need the min. You wouldn't use min. You just say ADR equals some value. Oh, I guess it could be min ADR. That might work actually.
It didn't.
Huh. You might have to calculate that separately. I just used the actual values. ADR equals minus 6.38.
Oh, well, I just did less than 0, but
I think you could say ADR equals min ADR. That ought to work. Let me just see. Yeah, that does work. That's clever. Then I don't have to hard code anything. And you can use max ADR also. But you have to say ADR equals min ADR, min of ADR.
arrival date, year and month, as well as how many people.
Oh, do we have to calculate people? Actually, I think we do. You can mutate that and just make a new variable called
You do
people.
that first?
Yeah, mutate people equals plus that would make sense because we're bringing it all together here. People. That's kind of cool.
I can't find mutate. Okay. So how do you know where that gets put in if we're going to do a select after that? It's the last one?
Yeah, wherever you want it. So the select will create a data frame in the order that the select variables are put in.
Oh, I have to list them all? I thought there was one where you could do like the ones between a certain.
You can if you have them, but I don't think you do in this case. And people you have to explicitly put in because it's new and it wouldn't know where to
Yeah,
put it.
that's what I was asking if it was at
Oh,
the
I
end.
see. Yeah, you can put it anywhere. I put it at the end, but
So these are all commas in between?
yep.
Filter, then comma, then mutate, then comma.
Oh, no, you're piping.
I'm piping.
Hotels pipe to filter, pipe to mutate, pipe to select.
How do you do the one that has you print everything that's in between a certain range?
It's the colon, but you would need to know the actual order of the variables. And
Yeah, I mean, if we just do it up through babies, I mean, then we wouldn't have the people one done, but
yeah, you can just do like ADR colon babies. Let me just look and see. I actually don't know.
no, arrival date year, right? Or I guess we want to do ADR as well.
Yeah, it's all over the place, so you can't use the colon operator
What do you mean?
because it would take all of them in between. If you look at names, there's hotel is canceled, lead time, arrival date, year.
Yeah, so we want arrival date year, arrival date week, arrival date month. Oh, and then adults, children, babies. Yeah, so the
Yeah.
stages would be.
And then ADR is way down at 28. Yeah. So we're gonna run out of time. Let me just close in, and then if you want to stay on, we can stay on. I'll send out the course agenda, but if you read this BuzzFeed article before Wednesday, it would be helpful. It's about Nobel laureates. It's a very short read. It's a 5-minute read. And then on Wednesday, we'll do parts 5 and 6, 2 more slide sets, which is about multiple data frames and joining them, and then we'll do a lab.
Okay, I'm all done. Do you have the answer or?
Yeah, sure. Well, do you want to look and see what I wrote? It might not be exactly what you wrote, but I piped hotels into filter, and I filtered by ADR equals min ADR or ADR equals max ADR. And I piped that into mutate to calculate people, which is the sum of adults, children, and babies. Then selected the variables. So I don't know why it's interesting. The arrival year and month is like 2017 in March and 2016 in March. I don't know if that means anything or not. There's 2 people in each of those bookings. I don't know. Not quite sure what. That doesn't really tell us why why those data were there, but we're at least able to find them and look at them, look at some data about them. So, all right, guys. I guess that's a wrap. Thanks a lot. Stop the train.
Thank you.
See you Wednesday.
Thanks,
Thank you.
bye.